Good morning, ladies and gentlemen, from the only guy here in a suit. Okay, so thank you. The biggest issue that all of us face, and this is in particular with IT projects, is of course what? What is the most difficult thing when you're trying to get together a system? It's not the technology, it's the people. And I'm an engineer, most of you have probably got a technical background too. We think it's going to be so easy. It should be like downloading a USB 3. I've got an idea in my head, I can plug it into your head and you get it and there's no corruption. But of course we know that we're organic beings and I'm afraid it does not work like that. Communication is difficult. I saw this in London the other day. And it sums up what happens on most projects. Data is being transferred between the parties, but absolutely no communication is taking place in any way whatsoever. So let's go back to February the 1st, 2003, and let's look at an organization that got communication completely wrong. That was no accident. They knew it was going to happen. They knew it was going to happen 10 days before. But they went ahead with it anyway, knowing that the astronauts would die, because in the end, it was easier to send emails rather than actually talk to each other. Unfortunately, this wasn't the first time that NASA had made similar decisions. They'd done it before, 17 years before, in 1986. Is there anybody here old enough to remember the Space Shuttle Challenger? One or two hands go up, the greybacks, well done. Okay. Certainly, it was one of those moments in my life that I'll never forget. At the time, I was designing and building oil platforms out in Gulf of Mexico. And I happened to be back in the Houston main office, and I walked into a lift, and there was a guy, an engineer, in tears. And I said, "What's happened?" And he said, "It's blown up. It's just blown up." And I said, "What, the oil platform?" Because we were commissioning an oil platform at the time. And he said, "No, the space shuttle." And I still remember the shock. I thought, NASA don't have explosions like that. It can't be the space shuttle, but it was. Again, they knew 4 hours before they launched that morning that everyone on board will be dead within 80 seconds of launch. But again, the engineers and the technical people decided it would be much easier not to have a meeting. And if they had a meeting, well, it's very difficult to talk to other human beings, look at my specification, look at my data. And as a result, 7 people died. So let's look at this flight and see what did actually happen. Of all the space shuttle flights that NASA had had up to that point, this is the one that they did not want to have an accident on. Does anyone know the reason? There was a teacher on board, an ordinary civilian, not a trained astronaut, first time ever. Her name was Krista McAuliffe, all-American girl teacher, teaching kids in our local high school, married, 2 kids. What on earth was an untrained astronaut doing on board one of the most complex machines mankind has ever conceived? The answer is politics. Ronald Reagan at the time wanted to show that he was very pro-education, so he came up with this crazy idea of putting a civilian schoolteacher in space. NASA said, "No way." Ronald Reagan then explained, "Excuse me, who pays your salaries?" And they went, "Great idea, sir." So we now have a project which is corrupted by politics. This is the way of the world. NASA then thought about this, and how can we spin this? How can we make it positive? And actually, they found a way. Because when the shuttle program was first started, Congress didn't really believe in it. And they said, "We will give you enough funding for 25 flights. If you can prove that this thing works reliably and safely for 25 flights, then we will reconsider all of the financing and we'll take it from there." This was the 25th flight. Everything had been good up to that point. So, hey, why not put an ordinary civilian into space? And NASA said, "Look, we can prove that it's safe. We'll put a high school teacher up." And they actually called the mission the Bus into Space mission. And so of all the missions that they did not want to have an accident, this was the one. And they did have an accident. To find out how, we need to go back. We need to go back into the culture of the organization of NASA. Before we go any further, are NASA a bunch of psychopaths that like killing their astronauts? No. They are really decent, honest people. I've interviewed many people in NASA about these two accidents, and they still get emotional, some of them cry, and you think, you're good people. You didn't intend for this to happen. Are they stupid? No, they have the highest IQ per square meter of any other organization on planet Earth, present company accepted, of course. They have the best procedures, the best governance, the best software, the best everything, the best comms. They have the best of everything in technology. So how come it went so wrong? First moon landing. And what was the most important deliverable? What was the one thing that they really had to bring back? The astronauts. Now, that's what we call a so what deliverable. It's really difficult, and it's the most costly and dangerous part of the entire mission. But if you get it right, the response is, so what? You did your job. What was the one work package that they had to deliver that made this project a success? Photo. Good. Now we're getting there. A photo of what? Sorry? The flag. Which, now, hang on. He said he did it for mankind, so presumably it's the United Nations flag. And of course, this mission had nothing to do with science or technology, had everything to do with politics, because that's the picture that they wanted. That proved that they'd won the race, the space race. Because up to that point, the United States of America were losing, and losing badly. If you look at the space race, the communists won, hands down, initially. The first object in space was Sputnik, built by communists. The first living object sent by mankind into space was Laika the dog, a communist dog. The first man in space, of course, was Yuri Gagarin. Okay. First woman in space. Oh, come on, Valentina. Marvelous lady, still alive. She was in London lecturing 4 weeks ago. Awesome lady, awesome. First spacewalk was done by Alexei Leonov. And so the Russians were doing everything first. The communists were beating capitalism, led by the USA. And you can imagine JFK one night after a couple of Jack Daniels saying, damn it, we're going to beat those communists to the moon by the end of the decade. And he then told NASA, and they said, shit. Because NASA did not want to go to the moon. NASA were charged with a scientific unmanned exploration of space. Suddenly, all of their programs for the next 15 years were cancelled, and they had to concentrate on one thing and one thing only, getting an American flag on the moon. And they did it, and it was fantastic. And on the first mission, of course, it was name the astronauts. First mission. Neil Armstrong, Buzz Aldrin, and well done, Michael Collins, the forgotten astronaut, who went on Apollo 12, probably the most important mission of all of the missions that they did. We're giving a prize of $100 to the answer. No one Googling it yet? Okay, it was Conrad, Bean, and Gordon. No one knows their names, because the first time you do something incredible, everyone goes, well done. The second time you do it, everyone says, boring. We all remember Apollo 13. Why? Because Tom Hanks was on board and we had to get him back. The last moon landing was Apollo 17. There should have been an Apollo 18, but by now the American people were bored. Bored, 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 bored. And that's the sad thing about high technology. Instantaneously, wow. And then the second time, third time, so what? Can't it do more? Now, they had a problem at this stage because by then they had 400,000 people working on the American space program. And if they cancel it, then that's 400,000 people, degree qualified or above, looking for a job. So what they needed was a new mission. And they came up with this idea of going to Mars. But there are problems. If you try and build a spaceship, especially with that type of technology, big enough to go to Mars, it won't take off from the surface of planet Earth. It's too heavy. So the only way you can do it is to actually build it in space. You're going to need a space station. Now, to actually build the space station, to build the rocket to go to Mars, you're going to need the Space Shuttle. It wasn't originally called the Space Shuttle, it was called the Space Truck. And it gives you an idea of what a small part it was in the overall Mars program. It was a truck that delivered men and materials to build the space station, to build the rocket to go to Mars. It went in front of Congress. Congress said, that's far too expensive. The engineers said, we can't do it for less. This is when the accountants moved in. Now, sadly, and I speak as an engineer, I'm afraid the world is run by accountants, not by engineers. And if you find that upsetting, then simply, if you are an engineer or a technical person, go away and get an accountancy degree, then you can run the world. Unfortunately, what happened was the accountants who moved in on this one said, yes, Congress, we can do it for half the cost. The engineers said, no, you can't. And they said, excuse me, who runs the world? Now, what we're going to do is we're going to use a very sophisticated technique called net present value. Some of you might know something about it. You actually move capital expenditure into the future. You discount it at a risk-adjusted rate of about 3.7, and actually it then becomes half the cost. Most engineers and technologists say, no, you still have to spend the same amount of money. Yes, you do, but you're spending it over a longer period of time. So on an MPV basis, it becomes cheaper. If you didn't understand a word of what I've just said, don't worry about it. The NASA engineers didn't understand either. But basically, what was going to happen was a lot of this stuff was going to be done in the future. But they were going to do the truck now. One of the NASA engineers, it's one of those questions, he must have asked it, and everyone would have gone, "Ew." Because he said, what is the point of building a space truck that's got nowhere to go and nothing to do for 10 years? It's a damn good question. The answer, of course, it keeps 400,000 people employed, and therefore it keeps virtually all the right congressmen in power at the Senate. But, hey, we can't say that to the American people, so now we have to post-justify it. They said, what else could we do with this truck if we're not building space stations for 10 years? Well, I suppose you could launch satellites. The engineer said, nope, you can launch satellites on unmanned vehicles for less risk and less money. It's about a third of the cost. The accountant said, well, that's easy. All you have to do then is make the shuttle capable of putting up 3 satellites. The engineer said, you can't just triple the payload like that. They said, well, that's an engineering problem. Deal with it. Now, how many are you going to launch per year? And they said, well, this is the most complex machine mankind has ever conceived. We reckon 5 times a year, max. And the accountant said, no, it doesn't make money. Make it 10. The engineer said, you can't just double the launch rate just like that, just for your spreadsheet. They said, excuse us, but who runs the world? Thank you. No, it doesn't work on 10. No, it doesn't work on 11. 15. Still doesn't work on 15. This is bad. 20 doesn't work on 20. 25. Breaks even at 25. Right, we want a minimum of 25 launches every single year for 5 years, either carrying a huge satellite or 3 small satellites. And according to our calculations, this thing makes money. The engineers just scratched their heads and said, you're all mad. And they said, yes, but who runs the world? So, by the time they'd finished uprating the space truck, it weighs 3 times the weight of the Statue of Liberty. Now, can you imagine that? What they asked the engineers to do was to take 3 full-size, full-weight Statue of Liberties and build an engine big enough to throw them 150 kilometers straight up against Earth's gravity and accelerate them from 0 to 30,000 kilometers per hour and do that in 11 minutes. Is that a big engine? It's a sort of Top Gear gone mad type engine. So they went to the clever people in NASA. Now, NASA is a huge organization. I've been to lots and lots of the centers. But I want to talk about 4 here, and you probably know them by their place names. The first place you might associate with NASA will be the Cape. What do they do at the Cape? They do takeoffs. They also do landings of the shuttles. The astronauts don't like landing back in Florida because the runway is quite short. They sooner land at Edwards Air Force Base in California. But of course, if you do that, it has a nice long runway, you then have to fly the shuttle back on a 747 back to Florida for the next flight, and that takes money. So the accountants encourage the astronauts to land in Florida. The other thing you do is assemble space rockets at Florida. They have this big white building called the VAB. Another place that you might have heard of is Houston. Have you heard of Houston? Why is Mission Control in Houston? Any ideas? Politics. Oh, well done. Okay, there's someone here that understands the nature of the world. It's called the Johnson Space Flight Center. President Johnson came from Houston. And if you build a big space center, it means lots and lots of jobs. And jobs equals votes. And votes equals power. So, where you have your head office? Well, it's where the power is, Washington. So these are the 3 main centers, but there's one more that I want to talk about, and it's where the rocket scientists are. Literally, the rocket scientists of NASA. Does anyone know where they are based? Well done over there, Huntsville. And the rest of you are thinking, what? I've never heard of Huntsville. Yeah, the Marshall Space Flight Center in Huntsville, Alabama. I'd never heard of it, and I'm an engineer. Now, the history behind this, and the reason why you don't know much about it, is that it's a little embarrassing. NASA has a little bit of an embarrassing history. Who was the father of the American space program? Well, it was certainly not JFK, although most of us think it was, because he made that speech. The real father of the American space program is this guy, meeting Walt Disney. And Walt Disney was about to make a family movie about his life, which you can still get. It's called We Aim for the Stars. Who or what is this guy? Verner Von Braun. And who or what was Verner Von Braun? Well, he was the world's greatest ever rocket scientist and engineer. There's no doubt about it. Unfortunately, he worked for an unpleasant individual and built V2s. Now, I'm a Londoner. These V2s used to fall on London. They actually killed some of my relatives. My grandfather was actually killed by a V2. From the time they launched these from France or Belgium or the Netherlands to the time they hit London, guess what the flight time of a V2 was? Slightly less than 5 minutes. It was 4 minutes. This was incredible. This was at least 15 years, 15 years ahead of any technology available anywhere else in the world. It was unbelievable. The way it worked, and I'm not going to bore you with too much technical detail, but it matters for the rest of the story. Let me just build you a space shuttle liquid-fueled engine, because these V2s use the same thing. You use a liquid fuel. Oh, it is liquid in this case. Liquid fuel, he used... gosh. Now that, by the way, is half the problem. Now, have we got a valve? Oh, excellent, lovely. Now, that's good. Now, that's much better, and actually that ties up rather well for the rest of the story, because now we have a valve on it, and it doesn't leak so much. Okay, but the nice thing about valves is that you can open them and close them. It's a controllable source. You have liquid alcohol, it's terrible waste, and liquid oxygen, and then you have a burner, and off it goes. That's the way it works. Remember the valves. You can either open them or close them, and in that case, I wish I'd managed to close it quicker than I did, but there you go. Okay. Now, in 1944, the Americans were arriving, obviously mainland Europe, and they wanted to find Verner von Braun. Verner von Braun was a very clever and very arrogant man, and he actually went to find the Americans. He said, I am Verner von Braun. And they said, God damn, Verner von Braun, we have a message here from the American president. Verner von Braun, you are an SS ranking major. Thousands have died at Peenemünde building your V2 rockets. We're going to take you to Nuremberg, find you guilty of war crimes, and hang you by your neck until you're dead. That's option number 1, Verner. Option number 2, welcome to America, Verner. Unsurprisingly, Verner went for option number 2, but to give you an idea of the power and the arrogance of this man, he said, now, I am not going to work for you, you are going to work for me and my team. And they said, well, where's your team, Verner? He said, they're on the train. So 118 Nazi rocket engineers were now given full American citizenship, big cars, big salaries, transported over to America. You're the American president. Are you proudly going to tell the American people about this deal? No, you're not. Where the hell can you hide 118 raving Nazi rocket engineers? Well, Alabama is a good choice. Okay, so forgive me if you come from Alabama. Okay. So Verner von Braun and his German team, make no mistake about it, it was a German project to get men to the moon. It was quite an amazing piece of German technology. And they built and designed the famous Saturn V's that got men to the moon. Now, as Verner got older, he had to worry about who he was going to pass his power over to. By the way, do you think that was a happy building full of happy people who sang at every lunchtime? No, it was an extremely unhappy place to be. Verner von Braun was one of those guys, I am a genius, I am always right. If anyone argues with me, they're obviously wrong because I'm always right, and they must be stupid to argue with me, and I don't want stupid people on my team. So the classic psychopath behaviors. As he got older, he had to hand over to an American. He chose a guy called Bill Lucas, American born and bred, but unfortunately trained Bill up in the same leadership style as he had, which is, I'm right, you're wrong, you disagree, you're out. So Bill Lucas took over after Verner went. And I'd just like to show you a fax. Some of you might remember that. Faxes. This was sent 1 or 2 weeks after the Shuttle disaster by a senior manager at Huntsville, at Marshall, to the head of NASA. The Marshall Space Flight Center is run by one man, Bill Lucas. As center director, he's established a personal empire where the only criteria for advancement is total loyalty to this man. Loyalty to country, NASA, the space program, means nothing. Many highly skilled manager scientists or engineers have been buried in the organization because they underestimated the man's psychopathic reaction to dissent. Nice man or nasty man? Well, unfortunately, he got the job done, and so NASA left him to his own culture. And as a result, Marshall became effectively isolated from the rest of NASA. Now, I don't know if you can believe this, but in some organizations, departments don't talk to each other. Have you ever come across this? And of course, Marshall hated the boys from the Cape because they were no more than engineers. They hated the boys from Houston because they always got the glory. Houston, come back. Houston, we have a problem. Houston, Tranquility Base. And they hated the boys from Washington because they were accountants and lawyers. And of course, everyone in Washington, Houston, and Cape hated the boys in Marshall. This is not good. This is not teamwork. And communication breaks down. The boys actually did come up with a rocket engine for the space truck. It was going to be a liquid-fueled engine. It went in front of Congress. They said too much. And the NASA people said, good, can we stop this now and can we go back to what we should be doing, which is scientific exploration of space unmanned? And they said, don't be silly, we've got 400,000 people we have to actually give jobs to. And so that's when a congressman said there is an alternative way of throwing things into space. Yes, you can use liquid-fueled engines, but there is another type called solid fuel. Solid fuel engines, what you do there is you get yourself a thin metal tube and you pack it full of a high explosive called P-BAN. It's 5 times more potent than TNT. You then put your monkey or your satellite on top of this tube of high explosive, light the fuse, God bless America, and hide about 3 kilometers away. Because 1 in 20 of these things used to blow up on the launch pad. Now, why did they blow up? When you ignite them, it's like a controlled bomb. If there's any weakness anywhere in the tube, it'll burst the tube, and then it all goes off in a single explosion. Sounds very dangerous, and indeed they were banned for all manned flights, but the nice thing about solid fuel booster rockets is that they were cheap. So who won, cheap or best? So now NASA went through a huge cultural change. For the first time ever, it became apparent that cost would need the same considerations as usual design purpose and rate safety before. They'd never had to worry about a budget in their lives, and that's how they came up with this appalling compromise called the Space Shuttle. The Space Shuttle, well, there's the Space Shuttle itself. The black stuff, of course, is heat shield, because once this gets up to 30,000 kilometers per hour, it has no fuel left, and the only way to get it back down to 0 kilometers per hour is to use the Earth's atmosphere on re-entry as a brake. It creates a lot of heat, and if there's any damage to those tiles, of course, everyone dies. The engines at the back, there's 1, 2, 3 of them, are liquid-fueled engines, so no American will ever be asked to go on a vehicle that is not powered by liquid-fueled engines, because the nice thing about liquid-fueled engines is that they have valves. Okay, this is the tank. It contains 6 million liters of liquid oxygen and liquid hydrogen. Nice stuff. It's 14 stories high. The fuel then gets pumped into the engines. Unfortunately, it's too heavy to take off. So then what they do is strap on, in the nicest possible way, the world's largest solid fuel booster rockets, containing tens of thousands of kilograms of a high explosive 5 times more powerful than TNT. You put those 2 huge unstable bombs onto the tank containing the 6 million liters of liquid oxygen and liquid hydrogen. Then you look for 7 volunteers. Okay. The way it goes, 10, 9, 8, 7, 6, now at 5, they open up those valves, put in the liquid fuel, set fire to it. You get lots of white smoke, but the thing is going nowhere. It hasn't got enough power. 4, 3, 2, 1. And if everything is looking good at that point, then they ignite the explosive charges in the 2 white tubes, and then it goes. Now, as soon as it takes off, it stops going vertically and it goes over at a slight angle. This is so that the astronauts can see where they're going to crash. The next thing is, you'll hear it on the video, they actually say, throttle back the main engines. And you think, throttle back? Come on, Jeremy Clarkson, throttle up. You need to get up to 30,000 kilometers per hour. No. They go relatively slowly, 3 times the speed of sound, until they get up to about 20,000 meters. Why? Basically, it's jet streams, fast movements of air in the upper atmosphere. They found that the control of the space shuttle was very difficult if you went very fast. So what they do is they go relatively slowly until they get quite high, and at that point they say to the guy in the shuttle, throttle up. And when he throttles up, those big liquid fuel engines kick up to what they call 104%, and you get max Q, maximum aerodynamic and G-force on the craft. And as a result, these white tubes flex with the stress. Now, do you remember what I said? If there's any weakness in those white tubes, it's all going to blow up. Come back to that later. As you go up, after about 2 minutes, the SRBs run out of fuel, they're thrown off. You then carry on burning the liquid oxygen and hydrogen until you get up to about 150 kilometers. You then dump the orange tank, which is now empty, and hopefully it burns up in the atmosphere, otherwise it lands on India. Okay, so that's how it works. What does this represent to aerospace companies? Of course, it represents huge amounts of money, and they all piled in. They all wanted a slice of the pie. NASA got worried about these solid fuel booster rockets, the white tubes. They said, we want to have these built by Aerojet. Why? Well, Aerojet are very good at building them, but most importantly, they have a factory next to the Mississippi River. And you think, what's this got to do with space? Quite a lot. It meant that they could manufacture these white tubes in single-piece units under perfect factory conditions, and then they could put them on the Mississippi River on barges and barge them around to the Cape. This is when the Mormons got involved. Have you heard of the Mormons? Very powerful religious group in America with an excellent choir. And a very good genealogical database if you're into those sorts of things. They had a company called Morton Thiokol that could build these solid fuel booster rockets. And they lobbied Congress and said Utah should get this work. That's democracy for you. And so it was decided that Morton Thiokol would get the job. And so Morton Thiokol from Utah, these Mormons, were now going to be subcontractors to the guys from Marshall. How well do you think these Mormons from Utah got on with the guys from Huntsville, Alabama? Now, straight away, as a project manager, I'd say that is going to be a huge problem on the project. That is where communication is going to break down, and that's where we have to do some work. Get them together, let them have a few beers. Oh, they can't have beers, they're Mormons. Well, get people together and have a barbecue, talk to each other as human beings. NASA, of course, didn't want Morton Thiokol, and so the relationship was sour right from the start. People. Next problem, there's Morton Thiokol. That's where you're going to build them. How the hell are you going to get them to the Cape? There is no river or sea connection between the 2 points. There is a mountain range in between. These tubes, 14 stories long, are so long they can't go on rail cars. They can't go on trucks. So the only way they could do it, I'm afraid, is not to fly them. That would be even more dangerous. But what they decided to do is to break them up into pieces, deliver them across America in pieces, and then reassemble them at the Cape. This is a bit like you can have your BMW straight from the BMW factory in perfect factory conditions, or if you want a 10% discount, we'll send all the parts over to your local garage, and Fred, the local engineer, can have a go at putting your BMW together in his garage. And I'm sorry to be so crude about it, but you can never get perfect factory conditions when you do field assemblies. So this is one of the tubes full of high explosive. This is the pathetic attempt by NASA at the Cape to create a factory condition. As you can see, basically it's tape and cardboard and scaffolding and plastic just to create a clean room environment. Your next problem is how you're going to stack these things together and stick them together. Well, welding is not recommended. So the only way you can do it is to have what we call a Clevis joint, which is a joint a bit like that. And of course, those joints are going to need an O-ring. And anybody here that knows anything about mechanical engineering will tell you that O-rings are extremely dangerous things because they move. They started testing these out in the desert, and it did not go well. The chief designer, Roger Beaujolais, you saw him in the video at the beginning, almost in tears. He designed the O-ring system. And they realized that they had blow-by and erosion. Now, what does that mean? It means that the O-rings are actually taking damage from the propellant. And if the O-rings burn right through, then, of course, it's going to have a case burst, and then the whole white tube will explode like a bomb. He went to his boss and said, we need extra money and extra time. The boss said, we have no extra money, we have no extra time, fix it. So they came up with the most amazing compromise. These O-rings are unreliable. We don't know how they're working, and they shouldn't behave in the way that they are. The boss said, yes, but they're working, and they said, that's not good enough, we need to have a backup. So they decided to have a second O-ring to back up the first one. This is a bit like you buying a car because you want your kids to be safe, and you're about to take it out of the showroom, and it's got a 5-star end cap, and it's really safe. And the showroom guy says, before you drive, very safe car. We've had a few incidents recently, and it's really interesting. People have reported that they're driving along the Autobahn, and the steering wheel just comes away in their hands, and we can't figure out why, but so what you do is you put it to one side, and then you say, hey, kids, pass Dad the spare. Now, we've thought this one through. There's a spare one on the back seat. They pass it over, and then you put it back on. You're going to be fine. So the double O-ring system, insane. It became what's known as criticality 1R. If it failed, you'd have last mission vehicle included metal erosion, burn through, and proper case burst, resulting in fire and deflagration. Have a nice day, you all. What does that mean in English? Boom, and everybody dies. Please use direct language. 1981, Crippen and Young got on board this thing, pressed the button, and it worked. We now know that they were just incredibly lucky. It's amazing how lucky you can be. They launched a second one, and that worked as well. So now we've got skill, judgment, and experience. No, you haven't. You've just been lucky twice. You get the bits from Morton Thiokol, you put on the main tank, you put on the orbiter, you take off, you go into space, you do largely pointless things, you then land it, virtually have to rebuild it. The interesting thing are the two white tubes. To make it look environmental, which it is not, after 120 seconds, they come away from the space shuttle. They came up with this crazy idea of little parachutes would open, and they'll fall back gently into the North Atlantic Ocean. They will then be retrieved by Navy divers, washed out with Perrier water, and used again. There's no way you should use anything like that again. Retrieve it, check it, find out how it worked, but don't use it again. But they decided to use them again. Roger Beaujolais, you saw him in the video, the chief designer of the O-rings. When he looked at the O-rings when they came back, he could not believe his eyes. There was blow-by, there was erosion. Every single O-ring behaved differently. Even the same position O-ring on different flights behaved differently. Now, if you had a program that ran like that, no one is going to touch it. It is full of bugs. Basically, this thing was full of bugs. But they've been lucky up to now. He got really scared, and after a few flights, he said, look, we're playing Russian roulette. One day, this is all going to go wrong, and people will die. He looked for a correlator. What was the common factor? Why is it was every single flight was different? The only thing he could come up with was the weather in Florida. It should have had no effect on the O-ring design at all, but it was the temperature in Florida, the weather, the day the shuttle flew, and it was not a perfect correlation. These things are never perfect. If you're interested in it, basically they had two effects. One was actually the stress of the joint, and the other one was what we call rotation. The tube actually rotates very marginally, and so the seal joint gets unequal pressure and it moves around. Don't worry about the details, but these things are never clean and clear cut. But it looks as if the colder the temperature in Florida, the greater the expectation that both O-rings would fail and the whole thing would explode. He took that to his boss, and his boss said, this is serious. You better go and see Dr. Lucas. Do you remember Dr. Lucas? These are his own words. When people go in front of Dr. Lucas, they know full well if they use words like think or feel or judgment to try and explain something, they will be shot down in flames. Prove to me that it's going to blow up. Well, we can't, sir, but we think there's a correlation. I don't pay you for thinking, I pay you for data. Sir, in our judgment with the lower temperature, I don't pay you for judgment, I pay you for data. Look, sir, I really do feel, stop right there. I don't do feelings. I'm an engineer, you're an engineer, no feelings, where's your data? Can you prove it's going to blow up? And the answer is, of course you can't, because you haven't got enough data. So where are you going to get your data from? More flights. We're now into catch-22 thinking. The flights continued all the way through the next couple of years, and the data started to pile up. But of course, statistically, because they'd had more flights and they were safe, this thing was becoming safer and safer. No, it wasn't. They were just being luckier and luckier. Lucas made it clear that under no circumstances was the Marshall Center or its subcontractors the cause for delaying a launch. This is insane. The 15th flight, 1 year before Challenger, was a winter flight. They now know that it was about 1 second away from blowing up, but they were lucky, and then they got luckier because after winter comes spring and summer, and of course we're now moving down the curve, and so there's less likelihood of an explosion, and of course it's getting safer and safer, but after summer comes fall, and then you move back to winter. All the way through that year, in 1985, they were launching and the engineers were crossing their fingers, hoping to God that the thing did not explode. But now it was going to be a winter launch. And of all launches, it was going to be the Christa McAuliffe launch, the one that they could not afford to have a problem with. They had problems. They wheeled it out, pressed the button, it didn't work. Software problem. Have you ever come across those? So then they had to reprogram the computer on board the shuttle. What they should have done is bring it back and put it in the VAB. But they didn't, because it takes time and money. So they left it out on the launch site, and people had to repair it at 90 degrees to its normal service position. And you can imagine people just make mistakes. The orientation is wrong. It's like gravity suddenly goes sideways in this room. You can imagine. They had a second launch attempt, and that went wrong. It wouldn't work. Software problems. By now, the press, the public were saying, "Come on, NASA, you're useless." The pressure was now on, and that's when their luck ran out. A weather front came across America. It created the coldest weather in Florida ever recorded. It rained, it got cold. Florida is normally quite pleasant, even in winter, but this time it got really cold. These are pictures of Challenger taken just before the spacecraft took off. The whole thing was covered in sheet ice from top to bottom. In terms of degrees Fahrenheit, guess how much lower it was than the January before? And it wasn't 5, it wasn't 10, it wasn't 15 or 16 or 17 or 18 degrees or 19 or 20 degrees lower than the year before, or 21 or 22 or 23 or 24. It was 25 degrees Fahrenheit lower. The engineers who designed the O-rings went crazy and said, "This is absolute insanity. You cannot launch the next morning. It will blow up." In fact, they even predicted exactly how the O-rings would fail and which O-rings would fail. They went to their bosses. Their bosses said, "We've got to stop this." And so the night before, they contacted NASA, Houston, and Huntsville and said, "Stop the launch." NASA went ballistic. How can you stop the Christa McAuliffe flight? We've already had 2 launch failures. You cannot have another one. And it's really important it takes off on time. The engineers were really arguing their case, but like most engineers, and I'm an engineer, unfortunately they didn't put it into management speak. They just went too much into the technical side. It was now late at night. People wanted to go home. They'd had enough of all this. They just wanted the launch the next morning. So the pressure was intense. I'm now going to show you a video of what happened, but let me add a little extra frisson to the mix. That Sunday, President Reagan was going to do the State of the Union address, and everyone knew that he wanted to talk about Christa McAuliffe. And if they didn't launch the next morning, that meant that Ronald Reagan would have to change his speech. The president would have to change his speech. The other thing was that the renewal contract for the solid fuel booster rockets was coming up in a few months' time. And of course, it shouldn't obviously affect anything that took place that evening. But of course, now their suppliers, Morton Tharkol, were giving them bad news. And that's bad if you're rebidding for billions and billions of dollars of extra work. Here's the video. Now, this is Roger Beaujolais. There's the double O-ring system holding in his hands. This is him taken 5 or 6 years ago. But of course, when all this happened, he was a much younger man. Okay, obviously in a great deal of stress at that meeting, and his manager's just not listening to him. They passed it back to NASA. NASA now had the answer that they wanted, which was, it's good to launch. The engineers predicted that it would be the right-hand booster that would fail that morning. Why? Because the sun comes up in Florida on that side in the morning. So it would actually, be the left-hand booster, because on the right-hand side it will be warmed by the sun. It would be the lower O-ring. That's normally the one that took most damage. The primary O-ring would fail as soon as they ignited it on the launch pad. If they were lucky, the secondary O-ring would hold it. If they were unlucky, the whole thing would blow up on the launch pad. As it turned out, they were lucky. The primary O-ring did fail on takeoff, and then the secondary O-ring just about held it. But when they went for throttle up, do you remember throttle up? As soon as they put dynamic force onto that O-ring, it blew open, and the whole spacecraft exploded. Okay, no one died. All the astronauts survived. This was suppressed by NASA, understandably, for the sake of the families for several years. That is the crew compartment coming out of the shuttle. It broke away. No one was dead at that point. They were all alive. They know at least 4 of them were fully alive and conscious and moving around within the spacecraft, because they found every single person, all 7 of them, with emergency oxygen masks on, which must have involved at least 4 people moving around the cabin. What killed them, of course, this had no ejector seats, no parachutes, no nothing, was actually hitting the North Atlantic and having their necks broken. That took 4 minutes. You can imagine what was going through their minds. Presidential report on Challenger was absolutely damning. NASA were brilliant engineers, but there was too much management and too little leadership and too little respect. There was low empowerment of individuals, low integrity, appalling communication, people just relying on emails, vague ownership of what the tasks and risks were, fear of escalation, don't tell your boss bad news, no one vision, I'm looking after my own department, I don't care about NASA, low trust levels, why should I trust anyone in this organization, silo mentality, my division is okay, complacency, we've always been okay in the past. So NASA fixed the problems, and they fixed them in the wrong way. And by the way, for those of you taking pictures, I will give you copies of these slides. They fixed the problem by basically bringing in more procedures and more governance. Does that really help? No, it doesn't. It has its role, but it's not enough. And so they started flying again. And by the way, they fixed the problem technically. They didn't have 2 O-rings anymore. That was stupid. They now had 3. So they started launching them, and everything seemed to be okay. And over several years, they launched 87 shuttles. And of course, everyone got complacent. And that's the problem. If you have success, you become complacent. Disasters happen when decisions are made by leaders who cannot remember what the consequences were last time. That's why I think there'll be another huge financial banking collapse within the next 36 months. I work with banks. Nothing has changed. They have more governance, they have more paperwork, but their mindset has not changed at all. It wasn't helped by their new CEO called Daniel Goldin, quite an energetic man. Faster, cheaper, better. When I ask for a budget to be cut and I'm told it's got impact on safety, I think that is a bunch of crap. Now, you can imagine if you're worried about safety and your CEO makes speeches like that, you leave. And that's basically what started to happen in NASA. What happened with Space Shuttle Columbia, this was actually going to be another teacher in space mission. You would have thought a single alarm would go somewhere in a building. There was a lady from India, there was a guy from Israel, every color, creed, sexuality, they were going to go up, do some experiments in space. NASA weren't really that interested in this mission. What they wanted was the next mission. The next mission was a big boys mission. It was a mission to take up some components for the International Space Station, and they were way behind schedule. So there's no way they wanted Columbia to actually go over on schedule because the next mission was so important. What happened? Well, it was a different technical fault, but basically the same management response. Bits had started coming off the main orange tank for the last few missions. It shouldn't have happened, but NASA said, well, it shouldn't have happened, but nothing bad happened. This is what we call deviation and normalization of deviance. On Columbia, a big piece of orange foam came off the tank and hit the spacecraft itself. Here's an animation of what happened. You'll see it comes off from this point here called the bipod. It's about the size of a laptop, and it hits the left wing with a speed of 730 kilometers per hour. Now, if I threw my laptop at you at 730 kilometers per hour, would you catch it? No, it would go straight through all the people behind you and probably go through the wall at the back. It's a lot of kinetic energy, mass times velocity squared. They saw it from the ground. They had photographs and video footage of it. The engineers on the ground started cranking up the Cray computers and started calculating how much damage would have been done to the tiles. Boeing ran their craze, and they reckon 17 tiles had been smashed off the craft. Even one tile slightly damaged, you're going to die on re-entry. They went to the management and said, stop the re-entry. We need to find out how much damage has been done to the wing. Now, it's up in space. Unfortunately, you can't see the wings from the actual cabin itself. The only way you can find out if there's damage is to do a spacewalk. And trust me, it is not like Mr. Clooney clambering into his spacesuit and doing brave things. A spacewalk is an incredibly complex thing to put together. They had the equipment to do it, but it would take 2 or 3 days of planning to get it right. And unfortunately, that meant that Columbia would be late landing, which meant that the next mission, the important mission, the International Space Station, would be severely delayed. So the engineers said, get out, have a look. The managers said, but if we go out and have a look, we might find that there's a problem. And the engineers said, exactly. And the managers said, exactly. Ron Didmore, under extreme stress, he's a good guy, but under stress, people do bizarre things. We didn't believe that pictures would be useful to us. We felt there was nothing we could have done anyway, so we decided not even to take them. There is no problem if you don't look for it. This went on for 10 days, not 4 hours late at night, 10 days. People going home, coming back in the morning, talking about it, meetings after meetings after meetings. These are 2 of the emails out of the Columbia Disaster Report. Any reports on the tile damage, or are we just crossing our fingers and hoping for the best? It kind of says it'll probably be all right. I'm just about to go to the airport to go back to UK. Could you imagine if I'm on the end of the runway and another plane crashes into our plane and bits fall off it? And the captain says, well, I'm on a promise tonight. So basically, yep, the plane is damaged. I'm not going to go and inspect it. I'm going to cross my fingers and hope for the best. The co-pilot kind of thinks that we're probably not going to die. Again, you'd be piling out of that plane thinking these people are insane. This is NASA. 10 days later, they brought it in. And everything that the engineers predicted would happen did happen. The whole wing would fold up. What that was about was that when they did the Challenger accident, they found that half the data was missing. What had happened to half the data, basically NASA employees, because they were so scared of their own managers, had destroyed the data. And so the investigation took much longer than it should. Now they seal the doors, catch the data. The investigation board was absolutely damning. Now, I believed this at the time, that they stood no chance. In fact, a rescue mission was challenging but entirely feasible. If they'd done that spacewalk, they would have found literally a hole straight through the wing. They would have left them in orbit for 30 days. It would have not have been like Apollo 13. They had plenty of food, drink, movies to watch. It would have been quite a nice holiday. And in that time, they would have brought another shuttle up. They would have rescued them shuttle to shuttle transfer. They had all the equipment to do it and the training to do it. They would have brought them back to Earth. And now it would be a Hollywood blockbuster with George Clooney and Schwarzenegger giving it wide. The Columbia Accident Investigation Board said that NASA had good technical skills, but too much management, too little leadership integrity. Does this remind you of anything? And in fact, there's a whole chapter saying this is the same accident. Yes, different technology, it doesn't matter. It's the same people response. NASA had not learned in 17 years. It's the same accident. NASA had to completely reform themselves, and when you go there now, it is unbelievable. Sadly, it's a much, much smaller organization, and it would never be the great NASA it was in the glory days, because you can have a bad accident once, you have the same accident twice. Quite honestly, people don't believe in you anymore, and most space exploration now in America is done privately. One vision, one empowered team, big picture, strategy, confidence, more leadership, less management, faster adaptive processes, agile, excellence, rotation of people between departments, a mentoring of people. Don't let the old people go. They have tacit knowledge. Partnership with suppliers, not where the boss, you're the supplier. More listening, more communication skills. All the engineers have to go on listening skills courses. Fierce conversations. Political correctness was thrown out of NASA. Fierce conversations. Engage, challenge. More stories. Stories are a brilliant way of getting minds in the right way. That's why Apple did better than Microsoft. They had a better story. Lunches. Get people together and let them talk whilst they're fueling their own bodies. The scientific explanation of this is absolutely 100%. You have better conversations. People are more relaxed. And fun. NASA was a miserable place to work. And as you know, your industries are normally fun. That's why talented people want to join them. And of course, if you've got talented people having fun, then you have the one thing you want. And as Albert Einstein said, creativity is easy. Just get intelligent people together and let them have fun. So I trust you're having fun on this conference? Yes. Okay. Now, hang on a minute. Hang on, let me finish it off. Are you okay for 2 minutes? Still with me? Okay, we got coffee and cake for you outside. NASA now, after 2005, were given a license to fly again. It's been up there many times, doing the most amazing missions and bringing back the most incredible pictures of us and our Earth, and of course, working with the Russians as well. Quite fantastic. Oh, by the way, we're there, aren't we? Is that Berlin? Yes, that's Berlin over there. Okay. 2011, July, sad day for mankind because that's the last shuttle flight, and quite right too. It was getting seriously old. They couldn't get the software anymore, let alone the motherboards to actually run this thing. It was getting old. And so that was the last flight. And now if you want to see our beautiful Earth from space, you will have to fly with the Russians. So who won the space race? Okay, my last two questions and I'll let you go. First thing, who decides from the time of the first accident right the way through to the last flight in 2011, who was the one person that decided whether or not the shuttle should fly? Please don't say the president. Can you imagine George Bush with a red button? Okay. Who's got most skin in the game? The crew. And I did this talk in London many years ago, 6 or 7 years ago, and a guy came up to me afterwards and said, "Well, Stevie," which I didn't like, "Well, Stevie, that was one hell of a talk, wasn't it?" And I said, "Look, I can hear you're American. Please, this is not anti-American. Please, it's not, if this had been a British piece of engineering, it would never have taken off and we'd still be discussing the paint color." And he said, "No, I don't take it as anti-American, but you did make some technical errors in your presentation." And I put them right, I think. I'm not a space engineer. Perhaps some of them are still there. But it were tiny things. I said, "You seem to know a lot about NASA." He said, "Sure as hell ought to, son. Worked for them for the last 15 years. And I thought, whoa, now I'm going to get a lawsuit or something. I can see this. And I said, "What did you do in NASA?" And by the way, this guy was about my size, my shape, and lack of hair. Guess what he'd been? Shuttle pilot. You imagine from the movies, the goddamn kick-ass, they are really boring, middle-aged slapheads like me. This guy was possibly one of the most boring people I have ever interviewed in my entire life. I asked him, I said, "I understand you can stop the shuttle flight." He said, "Yes, we can." And he had a very dry sense of humor, so I don't know if this is right, but it's a great story. I said, "What's the last thing you do to actually make it go?" He said, "We have a red push button in front of me, says launch commit." And I said, No, I hear it's all done by computer." He said, "Listen up, Stevie. Unless that button is pressed from within the vehicle, doesn't matter what the computer says, the SRBs do not ignite." I said, "It's a red button." He said, "Yeah, most people think before they press a big red button marked launch commit." And I said, "Oh, right, and what's the procedure, the protocol for pressing that button?" He said, "It's a 47-point checklist, and if I can remember it from memory, which I believe I can. At 47, what we're looking at, the main bypass hydraulic circuit, so there's more than 0.3 bar differential, we would go back to checklist item number 162. Assuming that we had cleared checklist item 47, we would move on to 46. Now, what's going through your mind? It was going through mine. I thought I could die listening to this explanation, and I want some coffee. And I said, "Could we just take it down to the last two?" And he said, "Well, you can miss a lot of data, Stevie." And I said, "In another life. What are the last two?" And you could see him going, "What?" Okay, second to last thing, we take the cover off the push button. Now, like you, I laughed. And he said, "What's funny about that?" And I said, he said, "Seriously, Stevie, you're getting ingress to the vehicle at 9 degrees to the normal orientation, and you're wearing quite a bulky suit, so there's a possibility, if not a probability, you could actually accidentally press that button when you did not want to." It's quite interesting because the button, the contact itself is 2 millimeter of linear travel, obviously normally latched open, and then it goes 2 millimeters into normally latched closed. This is the way he was speaking. It was unbelievable. And I said, "Well, assuming you've got the cover off the button, when do you press the button?" He said, "What? Apply a positive digit pressure." And I said, "Well, most of us call it pressing a button." He said, "I ask a question." I said, "Now this could be good. I can use this in my lecture. What's the question and who do you ask?" He said, oh, it's quite simple. I look around at the other 6 smiling faces in the vehicle with me, and I say, hey, I'm feeling lucky today. Are you feeling lucky? And if they're all feeling lucky, shit, we go. My final thought, and I'll let you go. If I could take you back to 2011, if we could go back into time to the last space shuttle flight, and I could negotiate with NASA and get you a spare ride on the space shuttle, if we could organize it, hands up in this room who'd take me up and who would fly the space shuttle. Hands up. Wow, there's a lot of mad people in this room. And hey, I do it one way, which is even more insane. But hey, we are all driven by different things. We are all diverse. We see the world in a different way. We see risks in a different way. And that's brilliant. That's what makes us so brilliant as a species. We are diverse. As Darwin said, it is not survival of the fittest. It is not survival of the most intelligent. It is survival of those most adaptable and willing to change. And that's what I love about Agile and everything that you're doing at this conference. It's all about fast-moving change, so you will survive. Trouble is, if you don't risk anything, you risk even more. Now, she was talking about sex, but sex and leadership are very similar. So, ladies and gentlemen, I hope you've enjoyed the talk. It's been a great pleasure. Carry on doing what you're doing. Thank you.